In this lesson, we're going to learn about what is arguably the most popular game known to game theorists, known as the prisoner's dilemma. Remember from last lesson that a game is defined by the players, the actions, and the payoffs, or the utility. In this lesson, I'm going to describe a scenario. We are then going to show what the players' actions and payoffs are. And finally, we're going to show how to represent this game in what is known as the normal form game. So the scenario is there are two players, two people, and they just committed a crime. For example, they robbed a bank. And unfortunately for them, they were caught. So when the cops caught them, they brought them down to the police station. This is a common description of the game. I promise I'm not making this up. They brought them down to the police station and put them in separate rooms. The cops then gave them a decision. They can either confess to the crime, which means they say that they did the crime along with their partner, or they cannot say anything. I'll refer to this as defecting. And the reason the cops want them to confess is because they don't quite have enough evidence to convict them without a confession. So the cops want them to confess. But what happens is, if the players confess, they're guaranteed a punishment. But if they both keep their mouths shut and don't say anything, well, they might only go to prison for a short amount of time because the cops don't have enough evidence. So let's look at this in a formal representation of a game. So the first thing we need to consider are the players. This is the easy one. And this is simply, I'll just call them player 1. You could call them criminal 1, criminal 2 if you want, but I'll just call them player 1 or player 2. The actions. So each player can either confess or defect. Remember, the actions list what each player can do, so we need to list this twice. This is player 1's actions. These are player 2's actions, even though they're the same. So finally, what are the payoffs? So this is going to be a symmetric game. So that means all we need to do is define the payoffs for player 1, and player 2's payoffs are going to be defined the same way. So what happens if they both defect? They both don't say anything. Well, this is good because the cops don't have enough information to really convince them, so they'll get a payoff of 3. You can think of this as how many years reduced in their prison sentence. What happens to player 1 if he doesn't say anything, but the other guy confesses? In this case, player 1 didn't cooperate, but he'll be found guilty based on the testimony of the other player. So in this case, he only gets a payoff or a utility of 1. But what happens if player 1 confesses, tells on his other player, on his partner, but the other player, his partner, doesn't say anything? Well, then player 1 will get rewarded because he confessed and the other guy didn't, so he puts the other guy in jail, and he'll get a reward of 4. And finally, if both players confess, well, then the cops have too much information, so they're both going to go to jail, but because they both cooperated, they each get a payoff, or player 1 will get a payoff of 2. Okay, so now we want to see how can we represent this in what is known as the normal form game, which is a matrix. So first we draw a box. Okay, we'll use some colors here maybe to make it a little clearer. So up here we have player 1, I'll abbreviate P1, and what can he do? He can cooperate or confess, or he can defect. Player 2 can either cooperate or he can defect. So now what each box will do, will list the payoff for each player. So what is player 2's payoff if they both cooperate? 2. What is player 2's payoff if he defects, the first one, and player 1 cooperates? See, he only gets 1. What happens when player 2 defects and player 1 defects, he gets 3. And when player 2 cooperates, but player 1 defects, player 2 gets 4. So the red corresponds to the payoffs of player 2. Now let's do player 1. So again, if they both cooperate, player 1 gets 2. Now the reason I list these like this is the payoff on the left, when there's not color coding, is usually the payoff to the role player. We call player 2 the role player because he can choose C or D, which defines which row of this payoff matrix we'll be in. Okay? When player 2 cooperates, but player 1 defects, D, C, this is a payoff of 1. Similarly, we can fill in the rest like this. Okay, so what we've shown is how to represent this scenario called the prisoner's dilemma in what is known as the normal form game, or sometimes you might hear it called a matrix game. So we'll write this out: normal form, matrix form, and sometimes you'll just hear it called strategic form. In the next lesson, we're going to learn how to actually solve this game via a solution concept called the Nash equilibrium.